Good morning, everybody. This is Aditya from World Startup from the Netherlands. For those of you who joined the previous webinar, I'm still the same guy. I've just had a haircut. This is a series that we're doing, and it's called the Indo-Dutch Innovation During Crisis. So we've picked three thematic focus areas. The first one that we did a couple of weeks ago was on biotech and on medtech. Today, we're going to talk about data and AI. And on the 9th of June, we have the final webinar of this series, which is going to be on smart cities and mobility. Before I go further, I'd like to tell you that this initiative is part of something called as the Resilience Society that has started in the Netherlands with over 140 different organizations combining or coming together as to solve the challenges of the COVID-19 that we have at this moment. And we are also scaling this initiative internationally, and the first country that we're doing this together with is with India. We also have similar initiatives popping up also with Ukraine in a couple of weeks, and also with Indonesia, Guatemala, and Denmark also. So please stay tuned for that. And I would also like to give a shout out to our partners who helped us with the promotion and also contributed with the speakers that we're going to have today. This is headlines and started by the Netherlands Embassy in Delhi, and also together with the Consulate General, the Netherlands Consulate in Bangalore, together with World Startup, Invest India, Startup India, T-Hub, TNO, and 10,000 Startups by NASCOM. And I'd like to quickly introduce you to some people that you'll hear in the chats and also in the question option. Melina is my colleague at World Startup Factory. She's going to help us manage the chat. But you'll probably also hear from Luisa or Ravleen from the embassy, and also Shivangi from Invest India as well. Yeah, and today we're talking about data and AI. Well, I needn't convince you about the importance of the subject in the current situation that we are in right now. We need it for the social distancing apps to, vaccine molecular sequencing, to enabling supply chains, to blockchain, to diagnostics, or much more. Today, we've gathered some experts and speakers that have been at the forefront of these thematic domains. And interestingly, half the entrepreneurs that we're going to hear today have pivoted from what their core solution is to be able to contribute to this to the solutions at this moment. This is still the new normal, doing events online. And we hope technology works out, but we're also depending on 9 different speakers having steady devices and steady Wi-Fi in their homes. So please expect some troubles. In fact, we ran into our first problem already. The Consulate General, Kurt Heiko, is unable to join us. We will be filled in by one of his teammates. But we're still all right. Those of you who joined the first webinar will know, unless I'm wearing my Batman sweater, we are okay. And if I'm wearing my Batman sweater, we are in the life-saving mode. A quick tip to who is joining us. We have 65% of the audience from the 300 people that we have right now from India. 30% is from the Netherlands. We have quite a few people joining us from Asia as well, from China, from Singapore, from Malaysia and Taiwan, but also from Spain, UK, Germany, Kenya, and US. So I see people are joining us from different time zones, and you're already introducing yourself over here. That's pretty nice to see. We have also created a LinkedIn group where we can continue these conversations later on. I will share that in a little bit. And I would also like to give a shout out to the Cambridge Institute of Technology. We have over 30 people from this organization joining us. And we have 37% of the audience is startups. And between 7 and 12% we have from corporates, governments, researchers and scientists, startup hubs, but also we have quite a few students joining us here today. All right, so that is a quick introduction from my side. And I'd like to bring on to the screen Akansha, who is filling in for the Consul General in Bangalore. Akansha, thank you for filling in last minute.
No problem. Thank you, Aditya. First of all, apologies on behalf of my colleague and Consul General Kurt Heiko, who was really looking forward to be with all of us this afternoon. Unfortunately, because of some technical difficulties, he cannot be here with us. But anyway, he's with us in spirits. I'll try my best to fill up in his absence. A very good afternoon and good morning to everyone who's joined us today for the webinar. It's an absolute pleasure to fill in on behalf of my colleague, Kurt Heiko. I hope you're all doing well, you're all keeping safe and healthy in these uncertain times. In the last couple of months, everything around us has changed dramatically, including how we connect, how we work together. So this webinar is actually a very good example of how we are working together in these times and how we connect. So yeah, as we all navigate these challenges that have been literally thrown at us, I strongly believe that entrepreneurs and innovators will play a crucial role in not only helping us, fighting this crisis, but also in rebuilding the society once we are, we enter into the new stage and new world as we navigate the challenges which are currently around us. The society will be very different from what it is now. Everything around us is already changing, and post-COVID also it is from consuming information to goods to how healthcare will be served to us to the entire supply chain, which is already going through quite some overhaul. So all these changes are literally, coming at us with quite some speed. So in these times, I feel that data and AI, it is already playing a very crucial role in healthcare, from tracking hospital capacity to identifying high-risk patients. And we have seen countries like Korea who have made very good use of data in not only tracking and identifying where the COVID hotspots are, but they came out with a very robust mechanism of test, track and trace. And India has also introduced the Aarogya Setu app in this regard. But also post-COVID probably in helping us, determining where and how healthcare can be provided to us. So I'm really looking forward to the talk of Mr. Arnab Kumar from Niti Aayog and learning more about the app and everything that went behind it. Indo-Dutch Resilience Platform is a very timely initiative, I feel, and it's very encouraging to see that already we have organizations like Niti Aayog, Startup India, TechLeap, TNO, CCAM, Government of Municipality of The Hague, and all these organizations coming together and joining this initiative very actively. I look forward to hearing more from the speakers, and I hope some joint projects will be sparked because of the interactions that take place on the platform today and the webinar. Please continue the interactions on the LinkedIn page that we have already shared details about, and look forward to the webinar. Thank you, Aditya.
Thank you very much, Akansha. Indeed, what we are. Thank you very much, Akansha. Indeed, this webinar series is not just about an event where we have speakers speaking, but we are talking about creating real-world collaborations and cross-country collaborations. So thank you for sharing that message. For everybody else, Akansha is going to hang around in the chat box as well. So please feel free to reach out to her. If you have any more questions for her, please use the ask a question option as well. Thank you, Akansha. Talk to you soon. All Right. Next up, I would like to bring up Arnab Kumar, who is from Niti Aayog. I believe quite a few of the audience members might have heard of him, or at least the organization Niti Aayog. And if you have not, you've at least surely heard of the Aarogya Setu app, which is the social distancing app from launched by the government of India. Arnab, welcome. The screen is yours right now.
Yeah, thanks a lot, Aditya. Thanks everyone, Ravleen and the team from the Dutch Embassy. First, quick clarification: I'm ex-Niti Aayog now. I'm moving back to the private sector. I came from the private sector 3 years ago and worked in Frontier Technologies team for Government of India. Was entrusted with leading a bunch of initiatives around technology, and I'm now moving back to private sector. So ex-Niti Aayog. But a phenomenal organization. I've been very, very proud of what we have been able to achieve in the last 3 years. During this conversation, and I'm allocated about 10 minutes, I'm going to talk about a few of the technology imperatives that we have taken, and we are very, very proud of the way we have moved around. The first and the foremost thing that people need to understand is that India is an extremely complex country. It's not a country which is equal from east to west or north to south. Very heterogeneous and not a homogeneous country. As a result of which technology solutions have to be understood from that perspective, and technology solutions have to be understood from the perspective of what is needed for India as a country. Very often, till about a few years ago, we could see a Western technology solution being explored and employed in India. Such solutions have mixed success, and I'll say that they have more bad implementations than good implementations of blatantly copying Western technology solutions. That is something that I've learned in the past 3 years. If you have to build for India, if you have to build for Bharat, you have to build for solutions that are actually try to solve for the unique problems and challenges that we have as a country. So Aditya, if you could go to the next slide, please. Next slide, please. Yeah. So before we try to understand why we want to solve for technology, what kind of technology solutions that we want to solve for, here's a quick snapshot of how India in 2030 would look like. We would probably be a US $10 trillion economy in real terms. In nominal terms, we will be about 45 trillion economy. We'll probably be the third largest economy globally. We'll be 1.5 billion people, largest globally. It's still a very, very young population. Average age will be about 31 years. Good thing is that we will have 1.1 billion internet users. And here is the paradigm shift. In comparison to what we are seeing right now, the internet users of tomorrow will be consuming more in vernacular, will be more from a higher age category, and will be more from people who will be first-time users. As a result of which, most of the internet will be consumed on the mobile and not on the desktop devices. And poverty elimination will become a reality. Now, with these parameters in mind, you'll have to build for solutions that actually work for India. And 1.5 billion people probably speak 100 languages or dialects. How do we solve for that? They have different types of sophistication and exposure to technology. How do we solve for that? Those are the things that need to be factored in when you try to build solutions for India. Next slide, please. Yeah, so this is, I don't know if a few of you have seen this cartoon before. This was just before India's Mars mission, the Mangalyaan, and we were honestly made fun of by the New York Times, saying whether India can even pull it off. And all of us know that the Mangalyaan mission was actually cheaper than the movie Gravity, and it actually succeeded in the first go. So rather than being fixated about what the rest of the world thinks of us, or how we don't have to copy them, we can solve for phenomenal technology leaps if we understand what is needed for us as a country, and we go ahead and solve that. Next slide, please. So when it comes to artificial intelligence, this is the area that I've worked the most in the past 3 years. There are 3 interrelated components. The first component is the data itself, which powers the engine of any AI solution. We are a very, very data-rich and data-diverse country. Almost every problem that can be solved through AI can be solved using data that are available in this country. but the problem is that they are unstructured, not cleaned, not properly annotated, not properly segregated information. How do we move from data rich to data intelligent? That is the one big question. The second big question is computing availability. And we have seen a lot of people, you'll see that, oh, we have access to computing. There's a huge difference between high performance computing and AI-specific computing. And in very simple terms, high-performance computing, which originated in particle physics, etc., they do a lot of write instructions. AI-specific computing, because there are so many layers of neural networks, one after another in a deep learning solution, they do a lot of read instructions, and then they train the individual parameters across these neural networks. The same set of data may be read probably a million times. That's why there's a difference, much more nuanced differences between an AI-specific computing and a high-performance computing, but that is the second axis that needs to be solved for. And the third axis is we have to be absolutely take a leadership position in advances in research and development. So that is something that we have to do, and it's both pure fundamental research as well as applied research that we need to focus on. Next slide, please. Yeah, so I will first talk about the data intelligence. So if some of you who have interest in artificial intelligence, there was a data set created at Stanford about 10 years ago based on imaging. It has led to almost all breakthroughs in computer vision in AI for the past several years. So that is the power that even a small data set can create. For India, if you go to one hospital, you'll get all the data sets that you need for any kind of solution, which is what we did. We actually went to one of the largest cancer hospitals in the country, Tata Memorial Hospital, and we tried putting all of the information that they have. And by the way, they had last 12 years, all radiology and pathology slides annotated, sorry, not annotated, digitized and kept on a server. We said, why can't we put an annotation engine on top of it and make it a layer that could train the best of the AI solutions? That is what we are in the process of doing. So that's the first aspect. The second aspect is the AI-specific computing that I was talking about. If you see the way people have approached, they may have a few petaflops here and there, which probably leads to silos of islands of excellence. Thanks for that, Sachin. Yeah, ImageNet is not a small database anymore. Yeah, but when it was started by Fefeli, it was a very small data set, but it has powered all of the innovations in computer vision. But thanks for pointing that out. So as far as AI-specific computing is concerned, what we said that why don't we have a centralized, massive computing infrastructure which is available to everybody across the country, and that's how we came up with the concept of Arawat, which is at least 100 petaflops of computing power, at least 20 petaflops of storage, and it powers all of our AI needs. It's connected to every single institution in the country through a national knowledge network, which is a high speed, very, very high speed internet connection. So that's the second aspect. Third aspect, if we can move to the next slide, please. Aditya, next slide, please. Yeah. So the third is no slide before. Yeah. So this is the approach to the research that we have taken, and this is if people are familiar with this quadrant, this is called the typical quadrant of research. There are three dominant scientists after which three quadrants are named, and the fourth one nobody should actually bother about. Firstly, the pure basic research, which is focused on the work that was done by Niels Bohr. The second is the pure applied research, which is by Thomas Alva Edison, and if you're familiar with their work, you will understand what I'm talking about. So we are trying to focus both on pure basic research for machine learning and artificial intelligence, deep learning, etc. We are also making sure that we move the research from lab setting to actual application, which is focused on India through pure applied research. And what is also important to us is that we have use-inspired basic research, which is inspired from the work by Louis Pasteur. So we are going to see a bunch of moonshots, etc. In AI in the next several years. For all these three ones, Bohr's, Edison's, and Pasteur's quadrant, we are in the process of setting up specialized institutions which will take care of seeding several research areas for ML and DL as far as India is concerned. Aditya, you can skip the next slide. We are running short of time, and go to the slide after. Yeah. So I was asked to speak a little about Aarogya Setu. I was involved in this Aarogya Setu from day one. This is the snapshot of what we have achieved through Aarogya Setu. We have more than 110 million users on the platform right now. We were the fastest to 50 million any mobile application anywhere across the globe. Basis about 30,000 people that are on the platform and have been tested COVID-19 positive. We have traced 400,000 Bluetooth contacts. 37,000 people who have been deemed high risk have been tested, and about 10,500 of them have actually tested positive. A testing efficacy of more than 25%. This kind of protocol is not seen anywhere else in the world when it comes to specialized COVID testing. We have an option of self-assessment, which is you self-declaring your symptoms. More than 75 million people have taken the test. And out of about 1.5 million people that have marked themselves as high risk, we have reached out to at least 800,000 people through a set of 100 doctors reaching out to them to make sure that their medical needs, etc., are taken care of. We have identified more than 3,400 emerging and potential hotspots at the sub-post office level. And remember, India has a mobile population of smartphone population of more than 400. We are still at 25% capacity, and we are still able to get phenomenal information. So at sub-post office level, we are being able to predict what could be the emerging hotspots 3 to 17 days ahead of time. The app itself is extremely light application, which is, we started with a data light product, which is the kind of interaction between the product and the server. App and the server is minimal. Now it's a data-free product because it's actually whitelisted by all telcos. This is available in Android. This is available in iOS. We did a very difficult engineering task of extending this to Kai OS, which is the Reliance Jio feature phones. And we also have an iOS version available everywhere in the country. Aditya, next slide, please. This is the timeline of the Aarogya Setu app, which some of you will appreciate. The concept, etc., started on 16th March. Beta version was released in 10 days from then. The app itself was released in 10 weeks. Under 3 weeks from the date of first start, and we launched in 11 languages, not just 1 or 2 languages. We had 15 million users in 13 days. We beat Pokemon Go's record. We had 100 million users earlier this month, and we are very close to open sourcing the app. All the concerns that people may have about privacy, security, we have gone to great lengths to address a lot of them. You should look at some of the press briefings that we have done. I'm happy to answer any question on India's AI-specific aspirations and as much as I know about Aarogya Setu. Aditya, thanks a lot for giving me this opportunity, and look forward to interacting with you.
Arnab, thank you very much for going through all of that in a very short period of time. I didn't know that you're officially moving on from Niti Aayog. I thought you were in transition right now.
Yeah, I actually had told Ravleen about that.
Okay, all right. Also, Arnab, I heard you have to leave soon, so I'm not sure if you can wait until Tjerk is done with his presentation to do Q&A.
Sure, I'll hang around. Please switch off my video. I'm just going to go and do a couple of calls and then I come back.
Okay, all right.
Yeah, you can drop your questions here.
Okay, sounds good.
Yeah.
All right, with that, we'd like to bring on our next speaker onto the screen. For the audience, it's good for you to know we're going to do a combined Q&A with both of our experts who are here. I'd like to give a shout out to the Netherlands AI Coalition, through which we could have Tjerk on board. Netherlands AI Coalition is an initiative that allows you to quickly start new AI projects and initiatives, gives you access to the most relevant people within the industry, and also they can be a partner for new investment impulses for AI in the Netherlands. But they're also starting to do more activities as well. Tjerk is here from TNO, which is one of the leading research organizations from the Netherlands. and he's going to talk through with us about AI's relevance right now, but also a little bit about how the government of Netherlands approached the situation with their strategy. Tjerk, welcome.
Thank you. Am I already online? I think so.
Yes, you are.
Okay, great. Welcome all. I'll try to keep it short. I have only 7 minutes. I was told I want to talk briefly about how in the Netherlands we, like many other countries in the world, jump to apps to the rescue, and talk a bit about the challenges around these data-driven solutions in a crisis time like this. Next slide, please. So in the Netherlands, the situation is and was that we, unlike many other European countries, we went into something that's called an intelligent lockdown, which means that a lot of responsibility was actually put on people themselves to uphold social rules, right? So to do social distancing, to not go to the supermarket too often. So the government created a set of rules and then was asking the population to conform to those rules. Next to that, they launched an appathon, so a hackathon for apps in 3 stages of recovery. So an immediate stage where we say what is to happen now, a midterm stage and a long-term stage. Many of these apps came from all over the world. Everybody could pitch in, and it was an interesting process in itself, which we could go into further later on if there's a Q&A time on what happened there in terms of who decides on expertise and when something is a good app, etc. One of the main issues with this app is that, and that's kind of the general rule of this slide, is that something like a 1.5 meter distance rule is not hard science, right? It's grabbed from the air combined with a practical stance on what is doable in society, but that becomes a hard technical demand. And this translation, especially in data science and AI, is very important to understand what it is that you're building and based on what kind of assumptions. Other than that, it's worth mentioning here that a lot of COVID apps, especially on social distancing, have been launched all over the world, but also in Europe. Due to the fact that it's only on a voluntary basis and the take-up is quite low, the problem is that it also doesn't yield a lot of results because you need minimum of 60%, I guess, as a rough estimate, in order for it to work. Next slide, please. What happened on a European level is interesting. There were quite some from the European Commission, but also from startups. There was a jump to start data sharing. And one of the main challenges of data sharing is to have standards and protocols in place to connect all these kind of local databases and to see how you can learn from that, right? So there was quite a range of sharing platforms that launched. There's some links at the end of the slide, and they're still going on. Most of them are medical, but definitely not all. So all kinds of data about logistics, about supply chains, about psychological effects, everything is springing up to share data. And Europe has been supporting startups through COVID-specific funding for these type of innovations. One of the main challenges there also in preparing data for all kinds of AI-related applications is often proprietary nature of AI algorithms. So companies not wanting to have a piece of the public data pie, but not opening up their algorithms. A lot of lack of trust, of course, in what is happening on the background on these apps on a population level. And a main challenge in Europe is also the difference of AI and data readiness per member state. So some member states are very digitally advanced and they can easily take up these kind of data sharing and AI apps, whereas others are in a way different mode of still digitizing and digitization of government. So this assumptions that you can have a one solution, even on a European level, is turned out to be quite naive. Next slide, please. What we do at TNO, well, we're part of this. We're on both sides, so we help startups. We also develop standards and protocols and help develop data platforms and also AI applications. What we did is we looked for the long term how you can develop actually a digital immunity passport based on self-sovereign identity, and how you can use that to help especially healthcare personnel back into caring home and nursing homes, creating a secure way of checking these people are immune or not. What is important there as well is that we also, via this National AI Coalition and other initiatives, try to help startups in getting access to data and actually using this. Because that's often one of the blockages, not only the technical parts, but also the legal, social, and ethical aspects of this. How do you make sure that you do everything right? Next slide, please. I'm not going to go too deep into a lot of detailed projects, but I think some points for discussion. What we see now in this COVID crisis around data and AI uptake is that we need, of course, data and AI is necessary building blocks and better understanding real-time and long-term impacts of COVID. There's a lot of opportunities to be taken, and I think now is also the time to properly do data collection and storage on this event, to use it for later times and to learn on. COVID is definitely an accelerator of AI uptake in government, is what we see. So many governments that were lagging behind are now understanding the need and the role to jump on the bandwagon, let's say. This new normal in society, what we're doing now and working on a distance and having this kind of government programs also communicating and asking you things to do via applications and mobile phones is a new kind of normal, and it also creates novel digital habits, right, and accompanied services. So there's a lot of opportunities there to think of services that we don't even have yet at the moment. One of the main challenges in the EU, as I said before, but also additionally, is the skills around AI, the data sharing infrastructure that's very important, the standards and regulation that is quite harmonized but still quite different in its application. And as I said before, the difference of levels of digitization of industry. In terms of investment, it's important to both look inward and outward, so not only look at countries themselves that are now investing a lot of money in their own industries and trying to think of a solution and reinvent the wheel all themselves, but we have to also look at how we can even broaden up and learn faster from each other. And what we see as a main challenge that's connected to that last point is we see also a new rise in digital sovereignty and supply chain sovereignty in general due to the problems we had in delivering medical supplies, etc. We also see this now in programs and digital innovation fundings, is that somehow even within the European Union we all now look backwards inside the country again as a way to innovate, which is not necessarily a bad thing to stimulate your own industry, but I think it's not the way forward in times of these crises, where if you look at the former presentation and the amount of users and data that are already available in India, we could never reach in 100 years, I think. So there you also have to see how you can actually make use of this and look for cross-fertilization. That was the main things that I wanted to share. I understand it's quite generic, but if you have any questions, please let me know. And looking forward to the rest of this discussion. Thank you.
Tjerk, thank you very much. And also these links that you shared are very interesting for different groups of people that are joining us. So please take a screenshot of this. But also it could be it is possible to come back to view the recording of this this webinar as well in the same link. You can come back to it and view this.
Happy to share the slides on LinkedIn if that's.
Yeah, we have the LinkedIn group, so you can also share the slides over there. Tjerk, you also heard from your counterpart Arnab from India. What did you think about that presentation?
It was impressive to see the speed and the amount of users in an application like that. As I said before, here in Europe, we tried many of these apps on a low-end basis, and the uptake is very low. So I think that is very impressive. And I also like the fact that you're stressing that you shouldn't copy what happens in the US or in Palo Alto necessarily, but that you, especially in this development towards AI, that you really should look at your own strength and see what you already have. And in terms of users and the next generation, will definitely come from a large part from India, also worldwide. I think it's very interesting to see what kind of cultural, social, and technical influences, innovations come from there. It was very interesting.
Right. You shared something about how the government is, how the government reacted to the situation right now. But can you also share with us how TNO and the Netherlands AI Coalition reacted to this?
Well, as said before, the government indeed launched an appathon, but the Dutch AI Coalition is looking more at this moment how you can use, on the one hand, and this moment to capture and collect very COVID-specific data, and second of all, also to really help startups to connect to these data sets and to governmental programs better in order to develop private or semi-public, public, semi-public, or private services based on this. And I think what is important there is that we try to do that in a way that we look at the kind of quadruple helix. So we generate this data and platform and helping startups not only for end-to-end or business-to-business or business-to-user, but also we look at the role for research and science in this as an important key factor there as well.
Yeah. All right. Sure. Is there a way for people to get in touch with you later on?
Oh, yeah, and that's true. I haven't put my email in the slides. I will share my my email contact in the chat. I guess that's best. Best thing to do.
Yeah.
And
as well. Are you back, or are you still in your calls?
Sorry.
I'm talking to Arnab.
Yeah.
Back on already. Okay. Seems like Arnab is not here with us already, but please pose any questions that you have for him in the ask a question option. Even if he's not able to join us right now, we will get back to you with answers. Tjerk, thank you very much. Please hang around, and the audience will talk to you very soon.
Yep.
All right. So actually move on to our next speakers, and this is the exciting part. We will start talking with the entrepreneurs at this moment. First, we will have Geeta Manjunath, who is the CEO and co-founder of NIRAMAI Health Analytics from India. So their company had they had solutions for breast cancer screening, but then they made a pivot to also do thermal screening and help with current challenges with COVID-19. Geeta, welcome onto the screen. I will leave it up to you to take it forward from here on.
Sure. Can you hear me right?
We can hear you fine, Geeta.
Cool. So go to the next slide, please. So hi all. Good afternoon. Good morning. This is Geeta. Happy to be here. Talking to you about what we are doing at NIRAMAI. So NIRAMAI is a deep tech startup, the most awarded, I would say, with international and national awards from corporates, and as well as such as Bill Melinda Gates Foundation, Google, Amazon, and so on. Next slide, please. We are the only Indian startup listed on the top 100 AI startups in the world. This list prepared by CB Insights, and so we are very proud of this achievement. Within 2.5 years of our starting of the company. So what do? Next slide, please. Sorry, I hear a echo. I hope I'm audible. NIRAMAI has developed a new way of detecting breast cancer. That's this previous slide, which is completely non-contact, non-invasive, and which works for women of all age groups, unlike mammography, which works only for women above 45 years of age. The previous slide, please. NIRAMAI Solution is applicable to women of all ages. In fact, even men get breast cancer and the solution works. And what do we do here? It is just measuring the temperature variations on the chest using a thermal imager. And we have developed machine learning based solution to analyze these 400,000 temperature points per person and generate a report which gives you a breast health score completely automatically. And you can imagine it is also affordable and accessible. And when you go to a rural area, you can do the screening without a doctor, at least a triaging to figure out who among these people need to be brought to the hospital for a further test. And in a hospital, it acts as an additional modality, or in fact, low cost and portable non-radiation based modality to screen women of all age groups. Next slide, please. So essentially, this is a computer-aided diagnostic solution using AI and ML. We use thermal images and demography information about the person and generate a 3-page PDF report completely automatically, and thanks to ML, deep learning, and and all the good stuff. Right. Next slide, please. So in this process, we developed what we call as thermalytics, which is thermal analytics, which is a technology, I can say, to analyze thermal images as such, right? We have about 117 plus semantic thermal patterns that we look for, in addition to the non-explainable deep learning statistical based features as well. So we take the images of the breast area using an infrared thermal imager or thermal camera, and it gives you images of the center, like the image that you see in the center. So this is basically giving a heat map of the temperature variations on the area which you image. Now, when you apply machine learning, a classifier on this, of course, there are multiple stages. You first have to detect which area to look at, where are the hotspots, and then do the analysis of each of the hotspots. So there are about 10 to 15 machine learning models in this whole solution. But the end result will be this NIRAMAI software, which gives you this report, which we talked about, as well as marks the area of abnormality completely automatically. The good part it is a completely no touch, no see, no radiation kind of a situation where women are very happy to go through this because it's a privacy aware solution. Of course, this has resulted in international patents, 9 granted in US and 1 in Canada so far. So the main thing is we don't look for lumps or hard tissue like mammography, which is also great, but in dense breasts, in women with dense breasts or under 45 years of age, it is hard to look for lumps in an X-ray. So what we do is we look for abnormal tissue activity. When there is higher metabolism, there is higher heat produced at that region. Also, there is higher vascularity around that place. And all these abnormalities are detected in the thermal image. Next slide, please. So while we develop this thermal imaging, analytics, and so on, the world was struck by this unprecedented challenge that was posed by COVID-19. And I know nobody ever on this world has seen the kind of situation that COVID-19 has faced us, right? So we said, okay, so we know about thermal imaging and we know the thermal screening is important and we know AI. Now, how do we sort of combine together and see what we can do to change this situation, address this situation, address this challenge, at least to some extent, so that we can help the world. Next slide, please. So what we have done is to utilize this thermal analytics, technology and expertise that we have, and we have come up with a fully automated community screening solution. In India, the most mostly most places do fever test using a thermal infrared thermometer, like the one which you see in the left side, which is does not maintaining social distance, and it's too close to the forehead, and there can be cross contamination from one person to another. This person himself is not wearing a PPE, so there's a lot of issues. As opposed to that, what we have developed is a completely automated. As you can see, there is a face with the temperature that is given. This is called NIRAMAI fever test. Next slide, please. So this is a combination of AI and thermal cameras and computer vision, all of this put together. So the benefits, and because I know you guys know about thermal cameras and how you can look at temperature as people come out of an airport or something, airport departure gate or arrival gate, I will just focus on the USPs, right? First and foremost, unlike these forehead thermometers, we maintain social distance. There is no person involved, right? So there is no cross-contamination that is possible. Multiple people can be screened simultaneously. Whoever is walking by, all of their temperatures are mapped, all of their faces are mapped, all of their forehead is detected, or like overall mean temperature is detected. They're wearing a mask, that part is removed. All this is done with computer vision, and then we actually have a log of every person with their temperature completely automatically. And of course, we raise a alarm if there is a temperature threshold, let's say 99.5 degrees Fahrenheit. Above that, if anybody has, we shout. Having said that, there's also a need for a dynamic threshold, because many people may be sitting in an airport, I mean, in an air-cooled condition, and so there can be a forced reduction in temperature, which also can be detected by looking at some kind of a modeling of the mean temperature of people moving around and so on. So there's a dynamic thresholding mechanism as well. And also in India, outside it's like 40 degrees centigrade. And so, I mean, like everyone looks high temperature. And so you need to sort of learn the threshold automatically. And the good part is it's all passive. So people are not scared. They're not sort of, worried and so on. Additionally, we do respiratory detection. And of course, at the end of the day, we can actually also do data analysis. Next slide. I'm going to finish. So with this, we have, in order to address the economic condition of India, we also have a single person test where every person comes, shows the face and goes, or a multi-person passes test. Next slide, please. We've also integrated this into a robot, which can do a completely automated screening. This robot is from Invento, which is called Mitra Robo, and this is used in hospitals for doing automated screening and visitor pass detection. Final slide, next slide. This can also be used for mass screening, where you have these camps and containment zones where multiple people can quickly come in and check their fever without anybody checking and so on and so forth. Thanks a lot. Happy to sort of talk more about how the AI works and so on in the Q&A session. Thank you so much.
Yeah, thank you very much, Geeta. These are some nice visuals also to see. Where was this? It seems like some recent pictures. Dr. Geeta, can you hear me?
Yeah, sorry, I hear an echo. So this was in Hyderabad, in the west, east side of India, southeast. So about 600 people were screened on a single day, actually in 6 hours. So that's the maximum. Of course, we have installed in several other places for screening as well.
Okay, this is very impressive. Please hold on. What we're going to do is we're going to mute you and cut your video for a little bit. We'll have Florent take over, and then we will do a combined Q&A. Thank you. Florent, you're joining us from Delft today? From the Netherlands?
Not from Delft. It's in our company's name, but I'm actually in the southern part of the Netherlands today.
Okay, all right. Florent, please take over from me.
Yes, perfect. Well, first of all, thank you to the organization for organizing the webinar today and for inviting me to talk a little bit about what our company is doing with AI and data on COVID-19. And thank you, of course, to everyone who dialed in from all around the world. To tell you a little bit more about what we're doing on COVID-19, I want to first tell you a little bit what we were doing before COVID-19. If you can go to the next slide, please, Nietzsche. Perfect, thank you. So our organization, Delft Imaging, specializes in diagnostic solutions for tuberculosis screening. And we've actually been involved in this since the early 20th century already. And what we did in the Netherlands with tuberculosis screening, what we were doing back then all around the world, is that we would take an analog X-ray film and a radiologist or a radiographer would look at that image to help determine whether a person had potentially tuberculosis or not. Now, when the digital X-ray came up, we actually would have a digital image, and that opened up the opportunity to analyze that image and look for potential patterns that could reflect the likelihood of another disease like tuberculosis being present. And we actually started the initial research on a solution that became computer-aided detection for tuberculosis, short for CAT for TB. CAT for TB is artificial intelligence for the detection of tuberculosis. And we actually started with the research on this in 1996 already, with the first project that we eventually started in 2007. So this was long before artificial intelligence is the hot topic that it is today, and before deep learning is what it is today. But back then we started with the very first version, and over the years we've developed it, started rolling it out further and further, and today the solution is used in 40 countries around the world, and has already screened more than 6 million people for tuberculosis. Now, coming back to COVID-19, when COVID-19 first came up in Wuhan, when it hadn't spread yet, it wasn't clear to us, and I think to many around the world, what the potential role of radiology would be in all of this. And because we, of course, know the RT-PCR test is used to diagnose and confirm the presence of COVID-19, but it quickly became clear as the virus spread around the world, that as health systems around the world became overburdened, that there was a very big role for both X-ray and CT to triage patients before RT-PCR, to have a fast way to detect COVID-19 and to triage before the RT-PCR test, and to alleviate the pressure on blood tests. So that's how we eventually came up with our CAT for COVID solution, computer-aided detection for COVID-19. And as you can see, a small example of that on the left bottom of one of the customers in Hungary that used it. So we used our technical infrastructure and our existing expertise and experience from CAT for TB, and we put it to use for COVID-19 screening. And if you go to the next slide, Aditya. So what we eventually did is that we developed two types of solutions, CAT for COVID X-ray and CAT for COVID CT. One for the X-ray, for the analysis of X-ray images, one for the analysis of CT images. And when I say we, I'm talking actually about two companies, two sister companies, Thirona and Delft Imaging. I work for both organizations, and Thirona specializes in artificial intelligence for medical imaging, and Delft Imaging specializes in screening for diseases like tuberculosis. So our CAT for TB solution, for example, is developed by Thirona and implemented by Delft Imaging, and our CAT for COVID solution was the same way. I want to emphasize that the idea behind these solutions is not to diagnose COVID-19, but it's to triage, to have, as I mentioned, a fast way to detect potential abnormalities in the lungs, and to help determine what the clinical pathway is that should follow. So what the input is an X-ray image and a CT scan, and the output is a probability score that indicates the likelihood of the disease being present, a heat map to show where those abnormalities are located, and what we also do is show a percentage of the affected lung tissue. Especially the latter is interesting, because if you look at the RT-PCR test, we can confirm with a yes or no COVID-19, but with radiology, we can also show what the disease progression and recovery is. Both solutions we have compared to the performance of radiologists. One of the solutions was just a study was published on CAT for COVID X-ray in the journal Radiology, where we also compared the solution versus 6 different radiologists from the Netherlands across 3 different hospitals, and we showed that its performance is comparable to that of a radiologist. Now we get to the question, how do you roll this out? We have an innovative solution. How do you get it out there as quickly as you can? We actually instantly made the decision that it had to be free of charge. And CAT for TB is a commercially available solution, but CAT for COVID we made available free of charge, because we knew that we had to act fast also in the case of the current pandemic, to make sure that we could get it out there as quickly as we could to help with the acceptance of the solution like this. And but of course the question is, the solution free of charge for the end user doesn't mean that there aren't any costs involved. So we've had multiple teams working on this for months now, essentially. And there's of course also costs involved, like setting up the cloud, storage costs. Customers can upload as many images as they want. And at first our company financed this, and we applied to a number of grants actually that came up for CAT for COVID. And while we're still financing a large portion of this, we also have now organizations that are supporting our initiative. For example, the Netherlands Enterprise Agency, the RVO in the Netherlands, is one of the organizations that's helping to finance the rollout of one of our projects in Ghana, actually, where we're rolling out the software to 55 different sites across Ghana. At the moment, the initiative is still expanding, and we'll continue to roll it out, and it will maintain to be free of charge as long as the pandemic requires us to do so. And at the moment, it's available in about 30, little over 30 facilities around the world in more than 20 countries, and a number also, I think, 2 or 3 in India as well. So this is a little bit the story of how we took our existing expertise from GAT4TB, pivoted to use it for COVID-19, and put it to use in the current pandemic situation. So I'll be available for the Q&A session later, and of course also on the LinkedIn group if there are any questions. Thank you for having us.
Florent, thank you very much. Yeah, you've also been doing some really impressive work, especially with rolling this out as free-to-use solution. Perhaps some of the other entrepreneurs joining us are also trying to do this. How are you able to do this?
I think at first it was a gut call where we said, like I mentioned, for people to accept this very quickly, for this to have an impact very quickly, we can't be drawn down in commercial discussions about, okay, how much does it cost? Have these organizations require funding? And I think it's good to mention that we developed this specifically for resource-constrained settings where, that need technological innovations like this the most, because they don't have the human resources available. And at first, as I mentioned, we decided to finance it ourselves, but we trusted also that as we progressed and we would roll it out further, that different organizations like the Netherlands Enterprise Agency would hop on board to support the initiative. So, and I would say to other organizations trying to roll out similar situations, look at different grants and call for proposals that are available. We have a number of them in the Netherlands on a European level, but also many on a global level from different organizations from out the world for a number of different applications, diagnostics, but also different types of applications.
Yeah. Thanks, Florent. Actually, interestingly, also with Dr. Geeta, her organization is also trying to roll out the solution as a philanthropy as well.
Yeah.
Dr. Geeta, you had mentioned that you're also looking at the possibility of rolling this out in the Netherlands with philanthropy. Can you react on that, please?
There was a question about how can we work together. So happy to sort of collaborate and then see how we can, improve the collaboration between the two countries by utilizing some of these solutions outside. So if there is anyone who's already having a camera, of course, we don't manufacture camera. If you already have a thermal camera, set it up and you want to try out, happy to sort of collaborate and then give your version. Right? That's what I was talking about. Because this is a time where multiple countries need to come together, technologies can come together, collaborate, and so from that perspective, I feel that's important.
Okay, all right. Florent, you said you're already you have some presence in India. How does it look like?
So we are in, I think, 2 or 3 clinics at the moment. I think there's a hospital in Mumbai and 2 other different places. And I think, as you mentioned also, Geeta, I was very impressed actually by the work you've been doing on breast cancer as well. I think it's been tremendous to see how different organizations and countries have come together to collaborate, companies, but organizations, and also on the country level. And I think, as I mentioned, we've developed it for resource-constrained settings, which is not every setting, of course, in India, but of course there are many areas in a country the size of India where there are human constraints in terms of interpreting lung abnormalities on X-ray or CT scans, where I think this can be put to use. So if there are other people that, from India that think that this could be a relevant solution also for their organization, please reach out to me as well, and we'll happily see how we can set that up for your facility.
Right. Thank you very much, Florent and Geeta. And I think there are some opportunities that the 2 of you should explore together. First of all,
let's catch up.
That sounds good.
Yeah.
Thanks a lot, Aditya. Great talking to you.
Perfect.
Thank you.
I'll answer the questions on the chat. Thank you.
Yes, please do. Also, Florent, we have to move on to our next speaker at this moment. This is Ajit Sahasranamam, who is the founder of Ongal. Yes. Let's give Ajit a second to come onto the screen. Yes, here you are, Ajit.
Hi, Aditya. Can you hear me?
Yes, we can hear you and see you very well.
Perfect.
Please take it over.
Thank you. Thank you, Aditya. Hello, everyone. Thank you first of all to the organizers for inviting me and having me here to share our experience of supporting our customers during COVID-19. So I represent Ongal, and at Ongal, like, we try to bridge the divide between data and actually making decisions. So we started with the aim of leveraging the latest advances in mathematical and computational sciences to solve large societal problems. And we work with enterprises to enable them to make data-driven decisions under uncertain conditions like the one that we see now. So what this crisis, if I may say so, has challenged us to do is to make our product faster and rise up to the occasion quite fast. So we work with companies, Fortune 500 companies in the FMCG or the consumer product goods sector and the banking sector. We work with clients in India and Singapore. So next slide, please. Yeah, so as we all know, like, the current economic challenges or the crisis, as some people put it, that we face was primarily driven by the disruptions to the supply chain. First from the supply side from China, and subsequently we are seeing a demand side crunch in different parts of the world. So supply chain, the disruptions to it is very critical. It's a very critical challenge that the pandemic has thrown to us. So our customers who are in the FMCG space and also like in other spaces, they face challenges along the value chain, starting with, let's say, the supplier aspect, where, let's say, their suppliers from whom they procure materials, they have exposure to the pandemic and consequently uncertainty. So the challenge is to maintain high supplier service levels despite this. And they face challenges in production. So when we speak to some of our customers, we realize that they operate with 1/3 of their typical labor force. So therefore, there is huge amount of uncertainty due to the shortage of labor force with the lockdowns and so on. And as we all know, like, people also are shifting their purchasing behavior from the offline brick and mortar space to more to online space. Now, this means a lot of rearranging of the supply chain on the network in a very, very, very short span of time. And this is, of course, very challenging. And the consumer buying behavior is also changing. It has been noted, we've also seen from data that people are shifting from buying discretionary products to more of necessity-based products. And these rapidly changing consumer behavior is throwing up challenging for accurate forecasting and so on. So these are some of the challenges, and these are some of the challenges at a high level that we try to support our customers with. So next slide, please. So how do we achieve this? So as some of these speakers, the first two speakers alluded to, there are like essentially three components. Like, one is the algorithm component, and the other one is the data component, and third one is like the existing tools that you kind of use to bring them together. Now, with respect to algorithms, so though it might seem like a long time now that COVID has been around us, it's just been 2 months. So we don't have much of a data on the havoc to the economy that COVID is causing, to the disruption that the supply chain is doing. So the existing machine learning methods, which are data intensive in the sense like a lot of data is required to derive insights out of them, are not very useful in this context. The second problem is like human decision makers, like in the various parts of the supply chain, they need to look at these AI tools and then trust these AI tools to make these decisions. If it makes a prescription, they need to understand why, which, as many of you might know, machine learning algorithms, especially the complex ones, are not very good at doing. So what we have done is we are developing probabilistic models essentially that simulate a large number of scenarios and even model the extreme scenarios and do cost benefit analysis in those contexts and give very specific inputs even with low data. The second part is like the algorithms are designed such that they can give you specific insights to the human decision makers. For instance, let's say if it recommends that a procurement of a certain raw material be ramped up from a particular supplier, it can also tell that because it is predicting that the commodity prices are expected to go up. So this makes decision making much easier. Now, previous speakers also spoken about using other data sources, and this is especially critical as of now. The reason being that, as I just said, like we are just 2-3 months into this situation, and we don't have enough in-house enterprise data to drive these insights. So what at Ongil we have always been doing, like, is we have been collecting data on the different aspects of supply chain, either directly from public sources, or we collaborate with others to collect various sources of data. For instance, we kind of collect and provide data on supplier risks, alternate suppliers, purely from public data. Then we also look at the logistics challenges that happens, right, from disruption in ports, movement of ships, or even the aircrafts and so on. And then we also look at the competition data on how the competition is strategizing by looking at publicly available information about them. And finally, the changing consumer behavior also, on how the consumers are changing their shifting their buying patterns. So next slide, please. So I'm just wrapping up. Yeah. So what have we delivered? So even as this crisis started, we already started working with our customers on one specific area. So I'm just sharing this one specific example of that we started working with our customers on. So this particular customer, they serve markets across different parts of the world, and they have their e-commerce activity that they kind of drive. They sell on e-commerce marketplaces. Now the point is, like, the purchasing patterns of the people who in this marketplaces, they continuously change, which they need to capture to dynamically derive sales strategy for each of the products that they sell. So which is what we have helped them with. Now the effect of consumer promotions is changing. The way people buy, what people buy, everything is changing. This has to be dynamically captured, and then the sales strategy has to be derived automatically, which is what we have helped them with. Now what we are moving towards is, like, we are taking into account supply chain constraints and bottlenecks, and we are also working towards giving them specific data-backed actions that we can prescribe to them. So this is what we do. So thank you for giving, I'm wrapping it up. So thank you for giving us this opportunity once again. So we look forward to talking to you to see how we can engage with each other on, like, the automation of supply chain that I just spoke about. So thank you, Aditya. Thanks a lot.
Ajit, thank you very much. Just to react on what you just said, you're inviting collaborations. But what kind of collaborations would you like to talk about?
Right. Yeah. So we are. I mean, as I said, the supply chain is a very, very general problem. We are open to working with like public institutions as well as corporates or private enterprises on any of the challenges that I just posed. Now, this is one kind of collaboration. The other kind of collaboration is, I was very happy to know about the data exchange that Dr. Timan spoke about today. So we are also hoping to collaborate on that front too. So probably I'll connect with them separately on that.
Okay. We'll also facilitate that for you, Ajit. Thank you very much. I wish we had time for more questions, but we have to move on.
Yeah, understood.
Yeah, please hang around. We have some more questions for you. All right. Next up, we would like to invite speaker Vidur Mahajan, who is the Associate Director of Mahajan Imaging from India. Vidur, welcome.
Hi, thanks Aditya. Thank you, the organizers. Thank you, Ravleen, for giving me the opportunity to talk about some of the work that we've been doing at Caring, which is the Center for Advanced Research in Imaging, Neurosciences and Genomics here in New Delhi. It's always interesting, when somebody else plays your slides, because all the transparency disappears. So I have a bunch of transparencies in the next 2 slides. Let's see how that goes. Yeah, so we can go to the first slide, Aditya. Great. Yeah, thank you. So essentially, for those of you who won't know, and many won't know, Caring is a translational product group. So essentially what we do is we take things that others have built and try to bring them into the clinical realm. And I thought that I'll use my 5 minutes to present, what is it that we do and what is it that we are now doing in the context of COVID-19. So essentially, we are the R&D division of a company called Mahajan Imaging. Mahajan Imaging is one of North India's leading medical imaging chains. We have 9 centers in the New Delhi region. We have some 50 doctors that work with us, and we do about 400,000 patients every year. Within Mahajan Imaging is Caring, and Caring has 2 divisions. It's a funny structure, but bear with me. The first division is called Carpal, which is the Caring Analytics platform, which is a dedicated AI division focused on development, testing, and deployment of clinical AI, and most of our work revolves in the field of medical imaging because that's number one, it's where most digital data is available currently. And shout out to my previous speaker. We are big fans of CAD for TB and now CAD for COVID, and we follow that work very, very closely. We work with 25 plus collaborators across the world, including Geeta ji's company, NIRAMAI. And then, all the big companies, so GE, Philips, NVIDIA, and then, to the 2 people startup out of Columbia University that maybe no one's heard of. So essentially at Carpal, what we do is we help take what others have built in the form of either algorithms or software or even, simple data tools. We take these into the clinical realm, and we've built the entire software pipeline for that. We also publish quite prolifically. We have more than 7 papers. We have more than 90 academic presentations across the world, most of them in the field of AI. Then the other division that's housed within Caring is called Caring DX, which is a clinical next generation sequencing lab. The 3 Ps of the future of medicine, so predictive medicine, precision medicine, and personalized medicine. Genomics forms the core of all 3. So we basically took a bunch of genome sequencers from Illumina and put them in the middle of an imaging center, and now we are seeing how that plays out. In summary, Caring is kind of a multi-dimensional research group. We are a room, like maybe a 15 feet by 15 feet room where we have clinicians, scientists, engineers, product specialists, MBAs, all sitting together trying to figure out how to use these tools, because there's so many people that are building AI or that are building analytics tools, and not so many that are actually using them. So we're trying to bridge that gap. Next, Aditya, please. And what are we doing, during the hashtag COVID times? Well, we decided to devote all of our energy to forwarding our research goals. Common theme amongst all the speakers. So everything that I'm going to say has, no commercial interest or commercial, goal whatsoever. So the first thing we did was, everybody was building AI for COVID, but there was really no data behind it. So we partnered with the CSIR, which is the Council for Scientific and Industrial Research, and started what you see on the left-hand side, which is called CoveBase. CoveBase is basically an attempt at building a consolidated clinical data repository of all COVID-19 patients across India. It is a very lofty goal. It's a very difficult goal, and it's fun, but it's painful. We are reaching out to hundreds of hospitals. And this is all volunteer driven. We don't have any funding. We don't have any government funding, nothing. It's a bunch of volunteers reaching out to hospitals across the country, collecting data. Then we have a bunch of volunteers, medical students that are curating this data into a structured format. And then the idea is to open source all of it to researchers across the world. No questions asked. Kind of open sourcing. And the other thing we're doing under CoveBase is, we are also building a world-class chest X-ray AI solution, trying to follow on the footsteps of, my colleagues from CAD for TB. the unique thing we're trying to do is overlay a layer of clinical insight over deep learning. And this is the data and the AI piece. Then we're also helping with the deep viral genome sequencing. This is a research project, again, we are doing with CSIR, where, some of our equipment is being used and our manpower is being used for genome sequencing of the virus. And then lastly, we published what is till date the largest meta-analysis of COVID-19 CT scans. So in summary, we've pivoted from being a product player to being more of a research player during these times, so that we can do what we do best, which is accumulate data, assimilate data, work hard, put in like 18 hours a day, and work with the government on helping the country in whatever way we can. Thank you so much.
Thank you very much, Vidur. We're first going to hear out also our next speaker, and then let's take some questions together. All right?
Sure.
Thank you. Please hang around.
Yeah.
Nicola, you're joining us from the Netherlands. You're also doing some of the things that Vidur and his team are doing, but you're also doing other things. Please tell us what your team has been up to.
Sure. Thank you. So, well, good afternoon, everyone. I'm Nicola Bonzani, CSO of Empicom, and I would like to, first of all, to thank the organizer for the opportunity to speak today, this webinar. And I would like to spend the next few minutes introducing Empicom and what we are doing at Empicom in these crazy times. So please, next slide. So Empicom was founded in 2017, and originally was founded because we found out that there was, let's say, a problem regarding the software developed for mostly biological analysis. So that software was lacking most of the, let's say, proper software engineering principle. And that led to buggy software, which produced unreproducible results. So we set off to bridge that gap and try to apply the best state-of-the-art software engineering principle with a deep understanding of the underlying biological questions. Since then, we expanded quite a bit. Now we do have offices in Amsterdam and in 's-Hertogenbosch in the south of the Netherlands. And we currently have more than 20 scientists actually working with us. And those includes immunologists, bioinformaticians, and software engineers. And what all these figures have in common with each other is a deep understanding of immunomics. Immunomics is the quantitative study of the immune system. And specifically, we focus on immune repertoire sequencing. It's a bit of a mouthful, but what that is the understanding and the sequencing of specific region in immune cells, the cell that actually fight diseases, to try to develop vaccines and antibodies faster or more effectively. So this next slide. Our main product is the immunogenomics platform. And what it is the first end-to-end SaaS platform for the management, analysis, and visualization of exactly this, immune repertoire sequencing of B and T cells. So what are these B and T cells? As I mentioned, those are the two kind of soldiers that fight different kind of pathogens, different kind of diseases. And you can sequence specific regions, so you can get the DNA sequence of these cells, and you can use that to create better vaccines or better therapies. But you need a platform to manage all this data because it's a staggering amount of data that is generated by the sequencing procedures. So this was a general platform that we built back then, and was built with the intention of, for instance, doing antibodies development or vaccine development, but specifically in the current times, of course, we found also a way to apply the current platform to the COVID-19 case. So next slide. So here is a concrete application for this, a concrete application that tries to find and identify response-specific antibodies. So those are, again, these specific cells, so to speak, that fight the disease. And the first thing to understand in such a setting is that each of us has millions of these different cells. And they're all slightly different from each other in their DNA sequence and in some of their characteristics. And this is very important because that allows our organism to fight different diseases. Of course, we don't have only to fight COVID, we have to find normal influenza, we have to find all kinds of other diseases. So we need that variety. But it also implies that each individual, as you can see from this picture, contains a multitude of these different cells. So how can you actually identify, for instance, if you have a survivor of a COVID-19, which of these cells are specifically tailored to fight this disease? So that's the underlying question, that's the underlying problem. And that's what we are trying to solve, leveraging some of the technologies that we have built in our immunogenomics platform, specifically the IGX Compare, which is a technology that allows to compare these different cells together, the sequence of these different cells, to identify which one are similar to each other, so to speak, so that perform the same functions of fighting the same disease. And the idea underlying this is to try to combine a pool of people that are, for instance, survivors of COVID-19, a pool of people that have been not exposed to COVID-19. And as you can imagine, as I already mentioned before, people that are survivor of this disease, they have in their system cells that are tailored to fight this disease, the red ones in these pictures, and other ones which are just fighting other things. So if you compare across a large population all these different cells, you can identify which one are in common, what all these individuals have in common in terms of their antibodies. And then you can try to subtract the things that are in common to, for instance, people that have not been exposed, the dark one, the red ones. And that allows you to identify the specific red ones and therefore accelerate vaccine development and treatments, because you don't have to test millions of different cells, but specific ones that have been identified in silico. So please, next slide. So what you're looking for, to conclude, is partner that have access to patient data to increase our partnership in these settings. And what we offer to those is free access to the platform and also in-kind contribution, given our expertise in the specific field. So I would like to thank everyone and take any question.
Thank you very much, Nicola. We're also going to bring Vidur also back onto the screen. We have a question from one of our experts here, Tjerk. He has a question for, well, both of you. How is COVID-related data captured and stored? Are you now labeling your data differently as well? Data that was normal but now becomes COVID stamped, for example.
So I can take a shot at it. Frankly, as much as we would wish to say that we are labeling it better or storing it in a more structured way, I don't think that's the case. Well, our group specifically, we are not treating COVID patients, so we rely on data from others. And as far as I know, it takes a very short amount of time for a hospital to get really, really busy with COVID patients. So by the time they figure out the mechanisms of either annotating or just storing it in a better structured way, they just get overrun with patients. There are, of course, hospitals in India. Most private hospitals have fairly robust EHR systems. They may not talk to each other, but then they at least store everything in a certain format. It's easier to get data dumps from there. But again, the way the disease is progressing, most data is currently in government institutes. And unfortunately, in India, most government institutes do not have HIS systems or EHR systems. So that is a challenge, which is what we are trying to address, where it's essentially a decentralized way of doing it, where you get data in 25 different formats, and then you have a small army of people, right? This is not computers, this is people looking at the data and filling up a form, like a very detailed ECRF form, in a hope that the day we hit 1,000 patients or 2,000 patients, we can draw insights from that.
In our case, our system is tagging based and is already handling sequencing and as well as clinical data. So in that case, it's sort of already built for that kind of annotation. It's just that the tagging system changes to the specific disease, but there is no, let's say, peculiarity in that respect.
Okay, I believe Turk's question also comes from this because TNO has a solution that can help for this challenge. So perhaps you can also talk to him about this. Vidur, there's a question from Sachin to you. His question is, does your forum also help early stage startups?
Yeah, very much so. So I'll put the link to the website of this project. We are basically looking for all the help that we can get. Some of the chat doesn't seem to be working, but essentially the idea is to open data to anyone who asks for it. The challenge is that we don't have much data right now, and so if you're a startup wanting to get access to the data, you can either wait for 6 months and hope that some data shows up, or you can join us and help on the development side and the outreach for actually getting the data so that you can be one of the early people to access it. But we have no bar. Like we have students, startups, big companies. IQVIA, which is like a global research giant, is helping us. And so everyone's chipping in with whatever they can.
Yeah, I believe the request from Nicola also, that's probably also something that you guys can explore together, the two of you. And also, Nicola, we will try to we will get you in touch with the Niti Aayog and also the Invest India to also see how you can collaborate with them.
Right.
Maybe a very quick word, because NPCOM has been announcing quite a few international partnerships. Could you maybe say a quick word about that?
So that's exactly what I was mentioning here. So we have a few partnerships starting up, some in the Netherlands and some in Canada and also in Germany. And those are indeed tailored around using the GX compared to try to identify the kind of antibodies that are shared across large population of survivors.
Okay, all right. So perhaps a link to your LinkedIn, if you can share that in the chat, it would be nice for us to also read about what kind of collaborations you're doing. It will also enable for people to think along with you about other collaborations possible with India and other countries. Yeah, cool. Thank you very much, Vidur. Nicola, please hang around.
Thank you.
And thanks for joining us. Yes. All right, we're going to bring on the next speaker. Meanwhile, I'd like to thank Marcel, who has shared some interesting links with us that have COVID-19 data sources from the Netherlands, but also from EU as well. So thank you very much, Marcel. And we're trying to bring up next up Chinaya. Oh, wait. Yes. Yeah, this should work. Yeah, and Chinaya is also, he's the CEO of Nimble Vision, and also a very curious story. We've heard of a couple of entrepreneurs who've made some pivots from their healthcare solutions to be able to contribute to the solutions for COVID-19. But Chinaya's team was in the IoT space, and they switched to healthcare to be able to do this. Chinaya, welcome. Please take it over from me.
Hello everyone. Good afternoon and good morning. I am Chinaya Math, CEO and co-founder of Nimble Vision Private Limited. We are Bangalore-based IoT startup. We are 3 years old IoT startup. We have been into smart water management using IoT and AI. And we have been recognized by Startup India and Startup Karnataka. And we have been winner of multiple awards for the impact, social impact and technology. Actually, the COVID-19 actually thrown an opportunity for us to come up with a solution called Nivarak. The Nivarak name itself means a problem solver. So since we had R&D expertise in developing IoT solutions, so we come in India, the country like that, it's a very vast country. We needed a solution where it can be deployed in a mass and it's a cost-effective way. If, Aditya, next slide. See, the first two slides, sorry, actually, because we have put only in 4 slides all the information. If you see the first 2 pictures, which summarize the whole problem happening in India and other developing countries, where the public health workers in public places, they are trying to screen thermal using a thermal gun, and a second health worker is trying to note down the personal details of the screened person. So this is a laborious and manual work where it takes long time to reach the screened information to the health authorities or the administrative. So there is a laborious work and doesn't help in government quickly acting on this. And if you see the second side picture of the problem, in any office or organization or the hospital, bank or small scale industries, the problem is that the employees need to go through the thermal scanning, and this again manual work is done, and there is no system which integrates the data with the existing HRS system. And also, if you see in India, the biggest problem in many small industries that we are using a biometric attendance. So unfortunately, we can't use this biometric attendance anymore. So these are the 2 problem statement we're addressing in our solution. So Nimarak, if you see the bottom, there is a simple IoT solution, which is battery powered. It is as small as a matches box, the IoT solution. And we have put all the intelligence in the mobile app. Here, the IoT unit and mobile app work together to make it a digital wireless thermometer. The IoT unit wirelessly collects the temperature from the person and it shares the data to the mobile app. The mobile app takes the photo and records the temperature, and it also collects the user personal details, geolocation, date and time. And that all the information collected goes to the one central repository to our cloud server. So this is the technology details. So next slide. So this is our app wise. So there is a one-time registration for each user where we take the photo and personal details. There are minimum personal details like email ID, phone number, and also if you are in an organization, you can use this for your employees. And also if you're a guest, then you can use for guest. And also has a provision to enter the Aadhaar number, or it could be your company. If it's a visitor, that is all is available. Next app screen, if you see, we are reading the temperature wirelessly from the mobile phone IoT unit. So it collects the temperature, then we save that temperature. So the mobile app saves all the readings taken like this. The concept is the way it works like in MyGate app. So you have all the local data on the app itself, and the same data is shared to the cloud server. So any user gets a login for both our web and app. And in web, what we also provide is that you can see all the information what you see in the app, and you can also export this data to Excel. And also it computes the attendance for all your employees end of the month. Each day, how many incoming, outgoing, all this computed using all the data and AI. So end of the day, you have an Excel where it can directly link to your payment mechanism. And if you see the IoT unit, it's as small as a matches box. So this is a portable, you can carry anywhere in the pocket along with a phone, and you can make it use. So this way we can reach the remotest part of India and still make that data available to the government in Delhi or anywhere in the world to take the action and data. Next slide, please. So use cases actually, if you see the biggest crisis in India saving COVID is a migrant migration actually. So currently, if you see all the police stations, railway stations, we can't use all these big thermal cameras or expensive items to be deployed anywhere. All we need is a cost-effective solution, which is portable, carried by hand. So all the police people can carry this solution in your pocket and still scan everyone in India. If you take Dharavi kind of the big plant, right, we can't carry any bigger gadgets. All we need is small and effective, cost-effective gadget. That is our solution. And in factories and in small offices, it acts as attendance register as well as thermal scanner, 2-in-1. In apartments, hotel, banks, this can also screen all the incoming people. And also in bus, train, flight, passengers, and all this data is captured. So we have integrated barcode scanning, if your employees have a barcode, and we are integrated speech recognition, and finally we're also integrating a face recognition for this. So recently we have won the first COVID hackathon conducted by government of Orissa and STPI. We got first prize in this one. So, and finally, what I would like to say, this whole solution costs not more than $100 for every unit. And if you have every features what so far have been discussed by all the other big companies, right? High-end cameras. This all is not required. With simple gadget, we can carry anywhere in the world. Thank you.
Thank you very much, Chinaya. I'm going to put you a little bit on the spot here.
Yeah.
Dr. Geeta has initially during her presentation, she talked about the problem with some mobile thermometers with not being able to maintain social distance.
Yes.
Would you like to react to it?
Yeah, I understood. See, there is a multiple ways how to do it. See, the thermal sensors, what we have been used in thermal guns, there is a multiple thermal sensors. And what we need is this IoT unit, you can calibrate each thermal sensors to create a safe distance. If you see, you can, in our solution, there is no need to hold it to forehead. Still the person can stand half feet and still that serves a purpose here. There is a need to be calibration is required. It need not have to have a high-end thermal cameras. Same thermal gun can be improved rather than holding it to the forehead, very close to forehead. You can stand at least half feet to 1 feet back and still you can take the temperature. That smartness you have to put in your hardware. That is what we have done.
Okay. All right. So, if Dr. Geeta, if you have a rebuttal, please let me know. Let's take that offline. No, this is
actually, Aditya, what I want to say is you are the people who have exposure in hardware from last 15 years. So we know all this hardware, whether it is a controller or a sensors, what is the best way to tweak them and come up with a solution which doesn't impact in either way, actually.
Yeah. All right. That's great to hear. Chinaya, you also mentioned about the need for financing right now.
Yeah.
Can you share more information about that?
Yeah, actually, this solution can help all the people in the world, not only in India, where we need to screen the people and have their data. Because even though we have Aarogya Setu, but unfortunately, right, there is no way we can get the data. So in our solution, what we can do is we can export our data to even Aarogya Setu app as well. And even the companies, if they have their backend data also can be integrated with our data. So that is what we can offer. But we need some financial support to make this solution in mass production, actually. So we are looking for around 50 lakhs. If it could be a grant or it could be an investment in our company. Either way, we are open for that, actually.
Yeah. And what would that investment allow you to do?
We want to manufacture this solution in bulk because many people are asking in India, many companies who want to have this non-biometric attendance. So we are at least have 100 people are talking to us, and many like Myntra and Flipkart also are talking to us. So all these requirement we want to do in bulk way so that our input cost is less, so we can pass on to that benefit to our buyers as well. Yeah.
Okay. So for the Dutch and the non-Indian attendees, Flipkart and Myntra are e-commerce platforms, the most popular ones, equivalent to
actually, if we are talking to Myntra on this, actually, they have around 400 people working on every shift. There are approximately 1,200 people. So what we have proposed them is they have barcode on their ID cards. So we are scanning their barcode and integrating our temperature scanning to that. So there is no need to wait for anything. Even you don't have a face reading because it's a privacy concern, which many companies have flagged, red flag. So we can't do the face recognition. So we integrated barcode, which simplifies the whole process here. Just the person comes, shows his barcode, and we identify who's the person, and we take that temperature and we send that data to their backend itself. So that is how our solution is helping, and it costs just $150 for any big company also, actually. So there's no need to buy a high-end thermal cameras to serve the same purpose. Since our company name says Nimble Vision, and we believe in being nimble, whether it is our solution or it is a design or it is approach. So that is our USP.
Yeah. Thank you very much, Chinaya. There's also another question from Sachin. He asks, doesn't Bluetooth and deep learning solve the challenges that you're having by using your own mobile?
We are not using Bluetooth because it drains your battery. So that is not, unfortunately, the best way to do it. We are using Wi-Fi hotspot, which sustains your battery life for 2 days in our solution.
Okay, that was short and very clear. Yeah. So if anybody is, besides investment, what kind of help are you looking for right now?
Actually, we are looking for connections because we are talking to a lot of people all over India, whether it is the factories or the companies or the hospitals. So if anybody is looking for a solutions which is very cost effective and still you have all the data what we need, so please contact us. We can collaborate with all of you and help all India and other nation people also to come out of this situation quickly.
Yes. Chinay, that brings us to the end of this webinar. Thank you very much for hanging around. And please also join us in the LinkedIn group where people can connect with you too. I believe there are quite a few people that might be interested to talk to you there.
Yeah, thank you, Aditya, and all the team for this opportunity and giving me an opportunity to come to this forum and talk about my solution. Let's work together. Yeah.
Yes, thank you.
Thank you.
All right, that actually brings us to the end of this webinar. We went a little bit over time, but yeah, majority of you stayed with us. So we'd like to thank you for that. And I'd like to give out a shout out to two of my teammates. If you can bring Melina onto the screen. I am sitting in something that looks like a hacker den right now with 6 different screens in front of me. And I have 2 teammates who've been helping me through this. And well, they actually made this this happen. One of them is sitting next to me. This is Daniel. And then hopefully Melina is also able to join us in a second. So that is my colleague Melina. That's who we were talking to in the chat. But we'll also probably talk to either of them also on in the LinkedIn group as well. I'm going to go ahead and post the LinkedIn group, the link. Let's continue the conversation over there. Once again, this is the webinar series. So we do have another one coming up, the final thematic focus, which is smart city and mobility. And that is going to happen on the 9th of June. At 11 o'clock Central European time and 2:30 Indian time, same time as today on a Tuesday. Thank you. Hope to talk to you and connect with you personally on LinkedIn. Thank you. Bye.